When we're given four terms, we're going to use a new kind of factoring called factoring by grouping. Now there's a few ways you could do it. I've tried using a new method that I really like, so I'm going to show you that new method that I've never used before. I like it because it's going to be familiar to you. We're going to use a box to do this factoring. So this is not the traditional way to factor by grouping. If you want to see that, I guess you can ask me in class or just Google factor by grouping, and I'm sure you'll find thousands of videos of the ordinary way to do it. But let me show you how the box method works for factoring by grouping. Once again, we do this when we have four terms that we're trying to factor. What we're going to do is first check for a greatest common factor between all four terms. We don't have one this time. They can't take an x out because they all don't have an x. That first one has a 1 in front, so there's nothing that all four terms have in common, but always, as always, check for greatest common factors first. So the way grouping is going to work is you're going to put all four terms in the box and put them in order. I found that if you put these in out of order, it does not always work. So put all the terms in order, I mean like across and down. So x to the third minus 3x squared, then negative 16x, and then finish with 48. So put them in order, in descending order like that. So all four spaces are filled out in the box. As we've done before with the box method, we're now going to look across rows and columns for greatest common factors, things these have in common. So negative 16x and 48 are both divisible by negative 16. Make sure you take out the biggest number or this won't work. Some people would recognize that negative 16 and 48 have a 2 in common, and that's true, but negative 16 is a much larger greatest common factor. It's the greatest common factor. So take out the biggest. Across the top row, those both have an x squared in common. And then do the same vertically, so look up and down columns and look for more greatest common factors. So x to the third and negative 16x have an x in common, and then finally these two terms can both be divided by negative 3. Remember, you always want to match signs on the outside. Alright, your factors are then going to be x minus 3 and x squared minus 16. Now, as we discussed in the last video, just because you factored with one step doesn't mean you're necessarily done with factoring completely. There may be more you can do to factor. If you ever get down to an x to the first power, you've factored that part all the way. So that first parenthesis is done. However, if you have x squared, you may want to check for more ways to factor. You may not be able to. It may be done. However, if you have x squared, what I would check for is the difference of two squares. In this second parenthesis, we do have a difference problem. There is a subtraction sign, and 16 is a perfect square, so this second parenthesis can be factored a second time. It does show difference of two squares, and so the way we'll factor difference of two squares, recall that we have two parentheses and then we take square roots, so an x and a 4, an x and a 4. The only difference is with difference of two squares, one parenthesis is plus and one is minus. Don't forget to bring down that first parenthesis, that x minus 3. So now this has been factored all the way. I have 3 sets of parentheses. Remember, an easy way to check these problems is to check by graphing. Graph your answer on your calculator as y1, and graph your original problem as y2, and as long as you see the same graph, one and only one graph, you know you factored correctly. Okay, so that's factoring by grouping using the box method. At this point, since the second problem is the same thing, I'd recommend you pause the video, try the second one on your own. Otherwise, let it play through. My work will pop up real fast, but check my answer against yours and see how you do. So I wanted to stop the problem there to see how many of you were yelling at the computer saying, no, it's not done, it's not done. If you got to that point, that's great. That's your first step. Hopefully, a lot of you guys out there recognize that once again, that second parenthesis could be factored again. Once again, it does show difference of two squares. Now, it's not always the case where there's always two steps. Sometimes you're done after one step of factoring by grouping, but in this case, you could factor again. It's a difference problem, and 9 is a perfect square. So hopefully you recognize that, and you came up with this as your final answer. X squared minus 9 would factor into x plus 3 and x minus 3. And then bring down your first parentheses as well, x plus 7. And so that should be your final answer. If you forgot to factor x squared minus 9, you didn't factor completely, so it technically is wrong. So make sure you, if you didn't do that, make that note that we can factor a second time. So there's our final answer.